It doesn't look like a typical comet where you see a beautiful tail of dust stretching away from.
Anubis tonight, one of the most respected voices in astrophysics, has said something that has stunned the entire scientific community. Harvard Professor Avi Loeb, the man behind the Oumuamua debate, has just reviewed new images of the interstellar visitor 3I Atlas. And his verdict is clear. It doesn't look like a typical comet. The footage, released by the European Space Agency's ExoMars camera, shows a glowing sphere drifting past Mars. No long shimmering tail, no dusty plume pointing away from the sun. Instead, what the camera captured looks engineered. And as NASA remains silent during its government shutdown, these new images raise an unsettling question. What exactly is 3I Atlas?
It's quite intriguing. It offers us a gift, a rare gift of a highly visible object that many of our space probes can look at. And
for months, astronomers across the world have been tracking the strange object known as 3I Atlas, the third confirmed interstellar visitor ever detected. And now, for the first time, we have visual proof. According to Professor Avi Loeb, the European Space Agency quietly released data from its ExoMars camera, captured during one of its orbits around Mars in early October. The camera detected a luminous sphere, bright, condensed, and slightly elongated, moving against the darkness of space. It happened just days after October 3rd, when 3I Atlas passed near Mars at roughly 29 million kilometers away. That might sound distant, but in cosmic terms, it's uncomfortably close enough for orbiters around the red planet to lock onto it. Loeb explains that the object was first discovered on July 1st, 2025, but what we're seeing now looks nothing like a frozen chunk of rock and ice. It appears anomalous, he said. It's large, bright, and perfectly aligned with the plane of the planets around the sun. That last detail, its alignment, has caught everyone's attention. Because natural interstellar visitors, by definition, don't follow our solar system's geometry. They arrive from random angles, cutting through the ecliptic at steep, unpredictable paths. But 3I Atlas doesn't. It's gliding within the same flat plane where the planets orbit, as if it had chosen that route deliberately. For Loeb, this encounter is more than coincidence. He called it a rare gift, a chance for multiple spacecraft to observe an interstellar object up close. And that's exactly what's happening now. ESA's ExoMars orbiter, NASA's Mars Reconnaissance Orbiter, even China's Tianwen-1, all with instruments aimed at the same mysterious glow. But as the first images emerged from Europe, a strange silence began to form on the other side of the Atlantic. When the ExoMars image was first analyzed, scientists expected to see something familiar. A bright nucleus surrounded by a faint tail of dust stretching away from the sun, the signature of every comet ever seen. But that's not what appeared on the screen. Instead, 3I Atlas looked like a self-contained orb of light, with only a subtle extension. Not a trailing plume, but a faint jet pointing toward the sun. That single anomaly breaks one of the most basic rules of comet behavior. Normally, as sunlight warms a comet's icy surface, it releases gas and dust, creating a tail that's blown away from the sun by solar radiation pressure. The tail always points outward. Yet, in the data Loeb describes, the bright streak goes the wrong way. It's facing the sun itself. It's similar, Loeb said, to what the Hubble Space Telescope captured back on July 21st, an extension of light directed toward the sun, not away. It's as if there's a luminous jet firing forward. That description stunned researchers because it suggests active propulsion, or at least a mechanism we don't yet understand. Could it be venting gases under internal pressure? Could it be tumbling in a way that redirects its emissions? Or, as Loeb dares to ask, could it be something more intentional? So far, no one knows. But what's clear is that 3I Atlas doesn't behave like any comet in recorded history. Its light curve fluctuates unpredictably, its trajectory is unusually flat, and its brightness doesn't fade as it should with distance. And while the European Space Agency has made its findings public, NASA's own high-resolution images, taken by the Mars Reconnaissance Orbiter's HiRISE camera, remain hidden from view. Why? Because just as those images were processed, Washington went dark. Just as the mystery deepened, something unexpected happened. On the week that NASA's Mars Reconnaissance Orbiter captured its closest and clearest view of 3I Atlas, the US government shut down. For Professor Loeb and many others, the timing felt almost surreal. The HiRISE camera, he explained, is half a meter in diameter and can deliver 30-kilometer resolution. The data was taken. We know it exists, but because of the shutdown, no one has seen it. Those images are sitting somewhere inside NASA's servers, processed by research teams who, according to Loeb, cannot legally release them until operations resume. In the meantime, ESA and independent observatories are free to share what they have, leaving NASA, the world's most powerful space agency, unusually silent. This blackout has sparked all kinds of speculation. Online forums buzzed with the idea that the delay might be deliberate, that NASA is hiding proof of something artificial. When asked about this, Loeb gave a characteristically sharp answer. "It's not extraterrestrial intelligence delaying the release," he said. "It's terrestrial stupidity." But even with that clarification, the absence of new data only fuels curiosity. Because the HiRISE camera, unlike ExoMars, can actually resolve structure, the reflective patterns, the brightness gradient, the precise pixel that tells us how much sunlight bounces off the surface. That would finally reveal whether 3I Atlas is made of dust and ice, or something denser, something metallic. For now, though, all we can do is wait, as the object continues its silent journey past Mars and NASA's images remain locked behind administrative doors. According to Avi Loeb, the moment NASA's HiRISE data becomes public will be a turning point. "A picture is worth 1,000 words, he said, and this one could tell us exactly what 3I Atlas really is. HiRISE, the high-resolution imaging science experiment aboard the Mars Reconnaissance Orbiter, is one of the sharpest cameras ever sent beyond Earth. Its half-meter mirror can distinguish details on the Martian surface as small as a dining table. Now, that same instrument has been pointed toward an interstellar visitor, a frozen artifact drifting between worlds. Loeb explains that the brightest pixel in the image will hold the key. By analyzing its reflectivity, scientists can estimate how much sunlight the object bounces back, and from that, infer its true size and composition. If it reflects too efficiently, it might not be rock or ice at all. It could be something smooth, metallic, or even manufactured. The scientific stakes are enormous. Never before has humanity had such a clear view of an object from another star system passing so close to a planet we've explored. Every agency, from NASA to ESA, even China's National Space Administration, knows that the upcoming image could rewrite what we think interstellar debris looks like. And yet, every day that the data stays hidden, the tension grows. Amateur astronomers have begun modeling their own trajectories, comparing ESA's brightness data with predictions from Harvard's Galileo project, the same research group led by Loeb himself. Their models show subtle variations in the object's path, micro-accelerations, tiny changes that shouldn't exist if 3I Atlas were just a tumbling chunk of ice. Some of those fluctuations even echo the strange forces recorded years ago with Oumuamua. So, once again, the same question resurfaces, the one that has haunted astronomers since that first interstellar visitor in 2017. If it's not behaving like a comet, then what is it? Among all the anomalies surrounding 3I Atlas, one stands out above the rest: its trajectory. Unlike most interstellar objects, which slice through the solar system from odd, random angles, Atlas moves perfectly aligned with the orbital plane of the planets. Professor Loeb emphasized this in his interview. It's aligned in its path with the plane of the planets around the Sun. To a physicist, that alignment is statistically absurd. Natural visitors, arriving from light years away, should have no reason to match the flat geometry of our solar system. Yet Atlas travels almost as if it had planned its entrance. That's why many astronomers call it the polite intruder, an object that slipped into the solar system without disturbing anything, following the same invisible racetrack the planets do. But to some, that politeness feels eerie. Its orbit shows another strange pattern, a sequence of close passes with major observation platforms: Mars in early October, the Sun at the end of this month, the JUICE mission to Jupiter in November. then Earth in late December, and finally, Jupiter itself next March, where NASA's Juno spacecraft could get one last glimpse before it disappears into the outer dark. Each of these encounters happens almost too conveniently. It's as if the object is moving along a route optimized for visibility, a trajectory designed to stay within range of our instruments. Could that be coincidence? Maybe. But as Loeb said, just imagine it was a technological object that selected this orbit for a reason, aligned with the planets around the sun. For him, that possibility is not fantasy. It's data-driven speculation, the kind of reasoning that brought him into the center of the Oumuamua debate years ago. And if he's right, then what's drifting past our neighboring worlds right now might not be just another icy wanderer. It could be the first clear sign that someone, or something, beyond our solar system, knows we're here. To Avi Loeb, science begins where curiosity meets discomfort, and 3I Atlas has become exactly that, a source of both wonder and unease. When asked what makes this object so different, Loeb doesn't hide his suspicion. He points to its brightness, its stable motion, and its deliberate-looking alignment. Just imagine, he says, that it was a technological object that selected this orbit for a reason. For most astronomers, such words border on heresy. Space is supposed to be filled with natural debris, rocks, dust, and frozen fragments from ancient stars. But Loeb has long argued that we should remain open to other possibilities. After all, nature rarely repeats itself in such specific, deliberate ways. And 3I Atlas isn't small. Based on reflected light, Loeb estimates it could span hundreds of meters, possibly larger than Oumuamua or Borisov, the two previous interstellar visitors. Its path is smooth, its rotation unusually stable, and its response to solar radiation inconsistent with that of a fragile, icy comet. That combination, stability, brightness, and control, reminds Loeb of something else: design. He's careful not to declare it artificial, but he admits it's anomalous enough to consider. He even revealed that he recently submitted a white paper to the United Nations, urging the creation of an international task force to analyze future interstellar objects. The idea is simple but radical. If we ever encounter something truly not natural, the world should be prepared, scientifically, politically, and diplomatically. Loeb calls this a wake-up call. Humanity, he says, cannot afford to dismiss what it doesn't understand. Because if 3I Atlas is indeed more than an icy rock, ignoring it could mean missing the most important discovery in the history of science. And yet, he tempers his excitement with a sense of caution, a cosmic humility that only experience can bring. If we ever find a partner in our cosmic neighborhood, he says, I just hope it's not a blind date with a serial killer. When Professor Loeb mentions a Black Swan event, his tone shifts from scientific excitement to quiet warning. He's talking about the kind of rare, unpredictable encounter that could reshape civilization, an event so improbable that no one prepares for it until it's too late. He draws a parallel with history. Humanity has always ignored the signs of great shifts until they arrived unannounced. Meteors, pandemics, even global conflicts. 3I. Atlas, he suggests, might represent that same pattern on a cosmic scale, a visitor we barely understand, approaching fast, while governments are distracted and observatories underfunded. Loeb imagines two futures. In the first, the object is natural, a massive interstellar fragment that teaches us how other planetary systems form. In the second, it's not natural at all. It's a technological relic, perhaps even a probe, drifting through the solar system with a purpose we can't yet define. That second possibility, however remote, is what keeps him awake. Because if it's true, if 3I Atlas is an engineered object, then its arrival was no accident. Its near-perfect alignment with the planetary plane, its well-timed encounters with Mars, Earth, and Jupiter. All of it could mean design, intent, and observation. In his interview, Loeb reminded the host that such an encounter wouldn't just be a scientific event, it would be a geopolitical one. When there's a threat from outside the solar system, he said, it's a serious matter for the international financial system. He believes the world should treat this as a form of cosmic preparedness, much like planetary defense against asteroids, but on a grander scale. The cost? About $1 billion, roughly the same as the Rubin Observatory in Chile, which now watches the southern sky. But Loeb wants another one in the north, capable of scanning the entire celestial sphere, so nothing escapes our attention again. Because, as he warns, we might only get one warning shot. The universe doesn't always give second chances. And if 3I Atlas is the first messenger of something greater, this could be the quiet beginning of humanity's most important chapter, or its last unguarded moment. For Avi Loeb, the solution is clear. Humanity needs eyes on the entire sky, all the time, not just telescopes that search for beauty, but a planetary defense network designed to spot anomalies before they reach us. He envisions a coordinated system, a pair of twin observatories, one in the southern hemisphere, like the Rubin Observatory in Chile, and another in the north. Together, they would form a complete celestial watchtower, capable of detecting even the faintest interstellar travelers before they cross our path. Such a network, Loeb argues, would cost no more than a fraction of the world's military spending. Yet, in his view, it would protect something far greater, our future. If there's a verified encounter, he says, the level of investment should rise by a factor of 1,000. He's not being metaphorical. Every year, nations pour trillions into defense budgets, preparing for threats that originate on Earth. But what if the next great risk doesn't come from rival nations, but from the stars? Loeb's proposal is both visionary and pragmatic. It's not about chasing aliens. It's about preparedness, about building an infrastructure that can tell the difference between an interstellar rock and an interstellar machine, about never being caught off guard again. And behind that urgency lies a deeper sentiment, curiosity tinged with hope. The question of whether we are alone, he says, is the most romantic question in science. If 3I Atlas turns out to be nothing more than a cosmic iceberg, we will have learned something precious about the universe. But if it's more, if it's truly a messenger from another intelligence, then this brief encounter near Mars might one day be remembered as the moment we were noticed. At this point, the conversation began to drift away from hard data and towards something more elusive, meaning. If 3I Atlas was not behaving like a normal comet, and if it could endure a direct hit from the sun's fury, then what was it really doing here? Among the voices trying to answer that question was astrophysicist Dr. Suzanne Fenner, whose work at the University of Geneva focused on planet formation. Her idea was as audacious as it was poetic. Perhaps 3I Atlas wasn't a relic of destruction, but a seed of creation. According to Fenner, young star systems often lack the time needed to grow planets from dust alone. Disks of gas and rock swirl for only a few million years before stellar winds blow them apart. That window seems too short for massive planets like Jupiter to form naturally. So, what if nature found a shortcut? Fenner's simulations showed that when a large interstellar body enters a newborn system, one already rich in gas and dust, it can act as a ready-made nucleus, a gravitational anchor around which material rapidly accumulates. In other words, a foreign object could jumpstart the birth of a planet. Her voiceover in a European broadcast captured the thought succinctly. Perhaps interstellar visitors are not accidents. Perhaps they are how worlds begin. In this view, 3I Atlas isn't a cosmic drifter or an alien artifact. It's a messenger of creation, a fragment from another star that once kindled planets in its own system, now wandering to pass that gift elsewhere. The idea found surprising support. Data models suggested that massive stars are far more efficient at capturing interstellar objects than smaller ones. And statistically, gas giants like Jupiter are indeed more common around massive stars. Fenner's conclusion was simple yet profound. The correlation might not be coincidence. Interstellar visitors like Oumuamua, Borisov, and now Atlas could be the very mechanism by which the universe sows new worlds. It's an elegant theory, one that replaces fear with awe. Instead of asking whether 3I Atlas is spying on us, it asks whether it once played the same role here, billions of years ago, when Earth was still dust and vapor. For a moment, the tone across scientific circles softened. The discussion turned philosophical. Could our planet owe its existence to something like this? Could life itself be linked to the quiet migration of interstellar seeds? In an online lecture, Dr. Fenner smiled faintly as she ended her talk. Perhaps every star system is part of a cosmic garden, and these travelers are the gardeners. The comment drew quiet applause. and a flood of speculation. Because if she's right, then 3I Atlas is not just a visitor. It's a reminder that in the vast, cold machinery of the cosmos, there might be purpose woven into the randomness. That creation might not be isolated, but shared, carried from one sun to another by these silent, ancient messengers. And while NASA's silence continued, that interpretation, hopeful, almost spiritual, began spreading online. For the first time since the blackout began, the story of 3I Atlas was no longer just about secrecy or fear. It was about possibility. As the interstellar traveler called 3I Atlas drifts deeper into the inner solar system, its secrets remain locked within the silence of space, and within the unreleased images sitting on NASA's servers. For now, the European Space Agency's faint photograph is all we have. A glowing sphere suspended near Mars, defying the textbook image of a comet. It could be ice, it could be rock, or it could be something far stranger. A fragment of technology, a relic from another civilization, crossing our path for reasons we can only guess. Professor Avi Loeb's words linger like an echo. The best is yet to come. In the coming weeks, as NASA's high-resolution data emerges, we may finally glimpse the truth, not just about 3I Atlas, but about our own readiness to face what lies beyond. Because if this object truly is a messenger, it has already delivered its message, that we are not watching the sky carefully enough. And as the world waits for the next update, one thought remains. Quiet, humbling, impossible to shake. What if 3I Atlas was never a comet at all?